Find dy over dx. The first one, y is equal to natural log of x to the power 2. Like, so what do you think? What rule are we supposed to use when we are finding the derivative for this one? Or what are we supposed to do to find the derivative for this one? What do you think?
I am not sure about this one.
So you get the power, you drop it, and then you write what is inside the same way it is. Reduce the power by 1, so it will be to the power 1. Now power 1 doesn't change like this. It will just be something like this. And then when you are done, go to the inside. Differentiate what is inside. So what's the derivative of natural log of x? How do you differentiate natural log of x? So what's the derivative of natural log of x?
I don't know.
So the derivative of natural log of anything, just get this same thing which is here. You differentiate it and then divide by that same thing. That's how you differentiate natural logs. So this is going to be differentiate x, that will be 1, and then divide by the same x. Okay, so the answer will just be 2 over x natural log of x. This is the answer. Are we good?
Okay, I want to get this straight. So other than the natural log, you
Mm.
have to get the variable clearest at the far end, differentiate it, and then divide with what it was. So
Yeah.
in that case, if it was natural log of let's say 2x, so I was supposed to say 2 then divide by 2x.
Yes. So the derivative of this one is 2 over 2x plus 4. The same thing which is here. You get that?
Yes.
Not just over 2x, but over 2x plus 4.
No, I didn't say that. Actually, I was thinking of something in my head. I didn't see what should be written in the.
I write it again.
No, I have already seen.
Alright. So you have y is equal to 4x plus 3 divided by the square root of 2x minus 1. What rule are we going to use here? Or
The shit, shit.
quotient rule, so that is v du over dx minus u dv over dx. Actually, what we are from using is a chain rule divided by v squared. So this is going to be v is what is in the denominator, that is a square root of 2x minus 1, and then u, that is what is on top, we differentiate, that will just give us a 4. Then minus, we get what is on top, which is the 4x plus 3, differentiate what is down. Now square root of 2x minus 1 is the same as 2x minus 1 to the power half. Okay, again, to differentiate this, you use the chain rule. I'll drop first the power, that will be 1 over 2, write what is inside the same, remove a 1 from the power, that will be negative half, then times. Now differentiate what is inside, that will just give us a 2. So see that these 2 and these 2, they'll cancel out, so remain with 2x minus 1 to the power negative half, okay, which I'm going to write here, 2x minus 1 to the power negative half, and then write whatsoever that was in the denominator, which is the v, square it. So I've got square root of 2x minus 1. Now square this. So this is the same as, I'll now bring this 4 in front, that will be 4 square root of 2x minus 1. Then you have got minus. Now, when you have got this 2x minus 1 to the power negative half, we can write it as 1 over the 2x minus 1, and then the power becomes positive half. But you know anything else, the power positive half is the same as square root. Are we okay?
Yes.
Okay, so that is going to be 1 divided by square root of 2x minus 1. I've noticed you like extending the fractions where it's not supposed to be. Please don't do that. Okay, this comma small fraction I've just ended here. This is for this one or for this one. Okay, remember on top we are supposed to have what? 4x. I've actually even not written it well. So the first one we're supposed to write was the negative 4x plus 3. And then instead of writing 2x minus 1 upon negative half, I write 1 divided by square root of 2x minus 1. So if it was you, you'd do extend this up to here. That would change the meaning if there was a plus here. So you don't do that. Make sure that you follow things the way they are.
Yes, sir.
And then this big fraction now is the one which is extending all the way from here up to the end. Now 2x plus 1 squared, it will just be 2x plus 1. Okay, the root and the square will cancel out. So I'm just going to clean the same one on top. Okay, so from here, so also write this as 4 square root of 2x minus 1, then minus, I can multiply this thing which is here to the one which is on top. So that will be minus, we are going to have 4x plus 3 on top. Okay, and then over square root of 2x minus 1, and then everything now divided by what is in the denominator, 2x minus 1, I mean plus 1 there. I don't know how has it changed to plus. I think this was supposed to be a minus, right?
Supposed to be minus. And then why are we still putting the 4x plus 3 in brackets despite multiplying by the numerator one?
If you remove the brackets, you change the meaning.
Mm-hmm.
You're going to change the meaning of the
Alright.
question because this negative means you are going to multiply the 4x and the 3. So if you want the brackets to be out, then distribute it to be negative 4x minus 3. And then merge what is on top as a single fraction. So multiply the 4 square root of 2x minus 1 with the 2x minus 1 which is down. That will just be 4 2x minus 1. Like if this square root and this square root they multiply, the roots are going to go. So just remain with what is inside. And then multiply the 1 times the negative 4x plus 1. That will be negative 4x plus I said plus 1, that's plus 3. And then divided by, multiply the two denominators. 1 times square root of 2x minus 1, that will just be square root of 2x minus 1. But remember, we also have a 2x minus 1 in the denominator. So that basically comes in front here, 2x minus 1, like that. So distribute on top, we're going to have 8x minus 4 minus 4x minus 3 divided by 2x minus 1 square root of 2x minus 1. So this is going to give us 8x minus 4x, that is a 4x, negative 4 minus 3, that is negative 7, and then over, we have got 2x minus 1, then square root of 2x minus 1. So this is it, we've simplified, and that's the simplest form. Is it okay?
Yes, sir.
Okay, now we want to find the derivative for tan inverse x cubed. If you've not mastered the formula for inverse trig function derivatives, then you need to know how to get it. So Either ways, you need to know one of those. Okay, you need to know one of those. So I'm going to say let this thing which is inside the brackets, I'm going to equate it to u. So let u be equal to x cubed. Okay, so I'm going to have y being equal to tan inverse of u. Now for us to have tan inverse of u, meaning that what did we have at the beginning? We had tan y being equal to u. And then if you want to find y, that's when you say tan inverse of u. Are we okay? Are we okay?
Yes.
And then we are going
Yes.
to find the derivative now. Okay, the derivative of everything. Okay, I wanted to say d over dx, but we don't have any dx here. We can just say that d over dx. Okay, in other words, we are just finding the derivative of everything. What is the what's if you differentiate tan, what do you get? What do you get?
Mm,
So by this time you should know that if you differentiate tan, you get sec squared x. If you don't know, you can find it. You know that tan is sin x over cos x. Use the quotient true, you are going to find the answer. Okay, so you differentiate tan, you are going to get sec squared y. And then after you differentiate the tan, also differentiate the angle, the y. Now if you differentiate y, if you differentiate x, if you differentiate t, if you differentiate z, you get a 1. But every time you differentiate y, you always add dy over dx because it is an implicit function. Okay, and that is going to be equal to, you are also differentiating u, so that is going to be u prime. I'll just put a prime because we are differentiating with respect to x. Now for me to remain with dy over dx, I'm going to differentiate both sides by sec squared y. So that is going to be dy over dx is equal to u prime divided by sec squared y. Are we okay first? Are we good?
yes.
Okay. Now by now I think you know that if I say that tan a is equal to let's say x over 2, you know that a here is the angle. So I can also write this like this. I write a triangle, I'm going to put a here, and you know that tan is given by opposite, so this is going to be opposite over adjacent, the 2 is going to be the adjacent. Okay, so that's the meaning. So even here I can write this like this is a right angle triangle. Now here we've got tan y is equal to u. Okay, tan y is equal to u, meaning that the angle is y. Now u is the same as u over 1, so this means that tan y is equal to u, which is the opposite. Then 1 is going to be the adjacent because tan is opposite over adjacent. Meaning that for me to find the hypotenuse, how do you find the hypotenuse? You get this side, you square it, you get this side, you square it, and then you square root. That means that the hypotenuse is going to be u squared plus 1 squared, which is just 1. Are you okay up to this point?
Yes, I am.
Alright. So we can now express this as where there is u prime, you're going to get this thing. Okay, you're going to get this. That is what you're supposed to get. Now I can, I which route should I take, which is going to be easiest for you here? Okay, you know sec squared y. You need to replace the identity. I hope you already know the identity for sec, like the relationship between sec and tan. Okay, like you know that sec, if you say sec x, this is 1 over cos. Okay, so I'm going to square everything, square here, square also here. And you know that 1 is the same as sin squared x plus cos squared x and then divided by cos squared x. So this means that sec squared x is going to be cos into sin, that is tan squared x, then cos into cos, that is a 1. Okay, so where there is sec squared x, I'm going to replace tan squared x plus 1, but in this case it's sec squared y, so this is going to be u prime divided by, where there is sec squared y, we're going to put tan squared y plus a 1. Okay, are we okay?
Yes, so there's something I'm trying to find out.
Yes,
Which identity is equivalent to sec if it's sec x and x? It's popping up, so before I lose track.
sec x tan
It
x.
goes with it. Yes, it goes with which one?
This one is I don't think it's an identity. If you differentiate sec, you get sec x tan x. If you
Oh,
differentiate sec, okay, and then you are going to get now u. Remember we said u was x squared, x cubed, right? So differentiate it. Okay, differentiate it because we are saying u prime. So differentiate u. That is going to give you what? That is going to give you 3x squared. Then over tan squared y. And then plus a 1. Okay, so this thing you're able to see here is a derivative, but again remember what is y is tan inverse of u. I don't know if you're able to follow this. So you don't want to have y, you only want to have x, so this is going to be 3x squared divided by, so we're going to replace here, so that becomes tan, okay, this is supposed to be tan squared y, but I can also write it as tan y, and then I put the squared outside like that. So this is going to be tan, but where there is y, we know y from here, y is tan inverse of u. So I'm going to put tan inverse of u, and then we square that. Every time you multiply tan with tan inverse, you are going to always get whatsoever the angle is, which is here. So that will be u squared. Okay, but remember also u is what? U is x cubed. So that is going to be
I
x.
think the way the information has been is being arranged, I'm getting a bit confused of how to follow it up.
So this is going to be the answer. That's the derivative for tan inverse of x cubed or plus 1. So if you are confused with this, I think one thing that you just need to know that because I was showing you the process if you don't know the derivative for tan. Now you can just know the derivative for tan, and that is going to, I mean for tan inverse, and that is going to make things much easier if you can get the derivative. I think that will be the easiest way I can show you. Okay, let me just show you that way. So I'm going to start. So if you have got, let's say you've got y is equal to, not sin, we are talking about tan, you can get sin if you want. So y is equal to tan inverse of x. I'll take tan the other side, okay? That means we're going to have tan y is equal to x. Are we good here?
Yes, I am.
Okay. That means from here now, remember we are using x. Okay, differentiate everything. If you differentiate tan, you are going to get sec squared y. Okay, and then differentiate also y, you are going to get 1. But every time you differentiate y, you add dy over dx. And then differentiate x, you're going to get a 1. So to remain with dy over dx, divide by sec squared y. So that will be 1 over sec squared y. Okay, to be dy over dx is equal to 1 over, but remember we have one, sec squared 1 is the same as 1 plus tan squared y, right? Then you can now replace, okay, the tan squared y. Remember what is y? Y is already here, okay? Y is already here. So that is going to be dy over dx being equal to 1 divided by 1 plus, instead of writing tan squared y, I'll write it as tan y and then squared. It's the same thing. And then this will be 1 over 1 plus. Now, it will be tan. Instead of having a y, I'll replace back a y. Okay, y means tan inverse of x. But remember, this is squared. This is going to give us 1 over 1 plus. Every time you have got tan multiplied by tan inverse, just going to get this term which is here. That will be x. But remember, it is squared, so that will be x squared. So this is the derivative for tan. Is that okay? Is it okay? So meaning that if I've been given any derivative, for example, d over dx, actually not for tan but for tan inverse. So if I've been given d over dx of tan inverse of x, I'm just going to write in this very same form. Okay, I'm going to say 1 over 1 plus. Now here we are talking of x cubed like this one. So this thing here changes according to the term which is here. Since now it is x cubed, that will be x cubed. But remember, according to the formula, it should always be squared. So raised to the power 2. And then always multiply by, you differentiate the angle. That will be 3x squared. So the answer then becomes 3x squared over 1 plus x to the power 6.